Hello everyone, it's Miss Redmond here again with your fourth and final summary PowerPoint from the Elements, Atoms and Compounds topic. This lesson is called What are Chemical Formulae? Formulae is the plural of formula, and we'll find out what formula is in a minute. If you haven't got one, please go and get yourself a pen and a piece of paper so that you can make notes and do any tasks that I give you as we go along. Here is your learning journey for this lesson, so feel free to pause the PowerPoint and write down those points. Okay, here's a question for you. What elements are in the compound sodium chloride? So while you're thinking about that, I'll tell you that this is sodium chloride. It's table salt. Sodium chloride is the stuff that you put on your food to make it super delicious and tasty, and the elements in it are sodium and chlorine, so the name gives you a clue. When chlorine is in a compound, it has "ide" at the end instead of "ine" or "ine" as we would pronounce it in English. So sodium chloride when it's in the compound, and chlorine with "ine" at the end when it's on its own as an element. It's good to become familiar with the names of the elements, although you won't be asked at this stage to name compounds. So have a go at these: magnesium oxide, potassium bromide, calcium nitride and carbon dioxide. Pause the video now and write down what elements you think are in each of those, and I'll give you the answers in a sec. All right, so magnesium oxide is magnesium and oxygen. Potassium bromide is potassium and bromine. Calcium nitride is calcium and nitrogen. And carbon dioxide, don't be fooled by the di, it's just carbon and oxygen. What is the minimum number of elements needed to make a compound? Write down your idea now. It's just a number, a single digit number. Have a go. And the answer is 2. All right, let's talk about what chemical formulae are. Remember, formulae is just a plural of formula. A chemical formula is like an ingredients list. It tells you what elements and how many atoms of each element relevant to each other. So let's think of a more everyday example. When you cook rice, you can use these ingredients: 1 cup of rice, 2 cups of water. Making sodium chloride is the same. 1 sodium atom, 1 chlorine atom. But what if I wanted to feed twice as many people with my rice? I'd just double my ingredients, right? So I get 2 cups of rice instead of 1 and 4 cups of water instead of 2. I've just doubled my ingredients up. If I wanted to make twice as much sodium chloride, I'd do the same thing. I'd just double it up. 2 atoms of sodium and 2 atoms of chlorine. But in reality, it would be more like this number of atoms of sodium and the same number of atoms of chlorine. So that number is so big that I can't even, what would we do? That's 1,000, a million, a billion, a trillion, a quadrillion, quintillion, sextillion? So 9 sextillion, 33 quintillion atoms of sodium. So this is why we use the relative number of atoms. So we just say how many atoms of sodium compared to the number of atoms of chlorine. If we tried to do calculations with these massive numbers, we would really struggle. In fact, there's a mathematical tool that we can use to do calculations with enormous numbers and very tiny numbers, but we won't touch that until year 9. But scientists like to simplify things as much as we can, so we talk about the relative number of atoms. Here's some examples of compounds. Water is a compound. Table salt, which we've already talked about, is a compound. And toothpaste is really a mixture but it contains sodium fluoride. In fact, most of the water that all of the water that you guys will see around you is a mixture, and all of the table salt. But in theory, you could have a pure sample of table salt, a pure sample of water, or a pure sample of sodium fluoride. And you've got formulas for each of these things. So water is H2O, table salt is NaCl, and sodium fluoride is NaF. So interpreting formulae. Have a go at these questions. So you've got water and its formula here. What elements are in water and how many atoms are there of each element? You've got the same two questions for each of those three formulae of those three compounds. So have a go, and the answers will be on the next slide. So pause the video, and the next thing you see is going to be the answers. Okay, so in water, there are the elements hydrogen and oxygen. There are 2 atoms of hydrogen for every 1 atom of oxygen. In sodium chloride, you've got sodium and chlorine, you've got 1 atom of sodium and 1 atom of chlorine. Or rather, you've got 1 atom of sodium for every 1 atom of chlorine. In an actual sample of sodium chloride, you'd have sextillions of atoms. And sodium fluoride, you've got sodium and fluorine, and again you've got 1 atom of sodium for every 1 atom of fluorine. Here's some diagrams of those things. So water, we've seen it loads of times. We've got 1 atom of oxygen chemically joined to make it a compound to 2 atoms of hydrogen. Here we've got in fact, these are ions, which we'll come on to again in Year 9, so this is a little preview. So we've got sodiums in green, and we've got chlorines in orange, and overall, there's a 1-to-1 ratio. So you might have covered ratios already in maths. That means that for every 1 chlorine, you have 1 sodium. And same deal in sodium fluoride. So really, our sodiums should be the same size in both diagrams, but they come from different sources. But it's still showing you that there's a 1-to-1 ratio. So for every 1 green fluorine, you've got 1 purple, in this case, sodium. All right. If you have some Lego blocks or some Duplo blocks at home, you can have a go at this this task. So you've got a key over here. The colours are random, you don't have to use these colours, but I've said I'm going to use red for carbon, blue for oxygen, green for sodium, yellow for chlorine, and purple for hydrogen. And you've got a challenge here of making these compounds: sodium chloride, water, carbon dioxide, sodium hydroxide, methane, and chlorine. So if you want to have a go at this task, pause the video now, go and get your materials, take a video and email it to your science teacher to see if you got the correct answer. Here's your summary slide. The chemical formula shows the relative number of atoms of each element in a compound. Relative number means how many there are compared to each other. We use relative number because the actual numbers would be really big in some cases, not in all. Okay, thank you very, very much for listening to these summary PowerPoints, and I will hopefully see you at school. Bye.